In this video, we're going to be doing an example on how to use ANSYS Maxwell to simulate a parallel plate capacitor. So let's start up ANSYS Maxwell. You can go to ANSYS Electromagnetic Suite 19.1 and then ANSYS Electronics Desktop. So in this program, everything is contained within a project. You can add high frequency simulation, you can add extractor, circuit, and then in what we're going to be doing today, Maxwell. So let's insert a Maxwell design by right-clicking on your project, insert, and then Maxwell 3D design. So this is our drawing screen. You can hold Alt and then click and drag to rotate around. You can hold Shift, click and drag to pan, and then you can hold Alt and Shift and then go up and down to zoom in and out. Okay, so let's draw a box. We can do that by hitting the draw box. So by default, it's going to draw a box just with your cursor. So we don't want that. So let's delete that. We can hit draw box again and then hit F4 to go into the drawing menu to add a variable. So let's draw with some variables. So we're going to center this. Let's make that negative and minus h over 2. So this, in this case, will be 12 inches, length will be 9 inches, and then height will depend on the type of substrate you use, but let's do 30 mil. Okay, the X size will be W, Y size will be L, and Z size will be H. We can hit OK, and then our box is drawn. It's way too zoomed in right now. To fit to screen, you can do Control D. Okay, also to pan around, in addition to holding Alt, you can hold the middle mouse button. Okay, so now by default, this box 1, let's change this to substrate. And then the material is going to depend on the type of substrate you use, but for this example, we're going to be using Rogers RO3010. So we can hit apply, and now we have a box of this material of the dimensions 9 by 12 inches. So after this is done, we can start to add our conductors. In this case, we want to select a face. So by default, when you open ANSYS EDT, you're going to be in object selection mode. So when you select something, it's going to select the entire object. Okay, so we want to select a face. To go into face selection mode, you can just hit F, and now when you hit this, it will just select the top face. Okay, so we're going to right click, go to edit, and then surface, and then sweep faces along normal. This will create a new object of this length that will eventually be our conductor. So let's enter 17.5 and then micron. Okay, so you can zoom in and see that there's a very, very small sheet up here. See, this is our substrate, this is our new conductor. But it isn't a conductor yet because it's by default the same material as what it was extended from. So let's change that. Let's call this top for top conductor, and then let's put this as copper. Okay, so now we can do the same thing for the bottom. F for face selection mode, hit this, edit, surface, sweep faces along normal, and it's going to be the same value. Okay, so now let's go back to this, call this bottom, and then change the material to copper. Okay, so let's just make this look a little better. We can change our colors by double clicking here, going to color. Then I'm going to make this a nice green, hit apply, and then you could see the middle thing is now green. Let's change our conductors to this dark red. See, the bottom's red now, and then same with the top. Okay, so now we have our capacitor. The only thing we'll have to do in terms of drawing is add air. By default, there is no air box surrounding our structure. To add it, we can hit this region. Now let's change this to absolute offset and then 15 millimeters. So now it will draw an air box. So next, we will tell Maxwell to use its electrostatic solver because we want to solve for a capacitance. You can do that by right-clicking on our design and going to solution type and then electrostatic and hit OK. Next, we have to add some excitation. In this case, we're going to be using a voltage, just a standard DC voltage. To do this, we're going to go back into face selection mode, and then we're going to select our top conductor. Although you may notice this didn't actually select the top conductor. This selected the top of the box. To get to the thing below it, you can hit B. So now let's assign our excitation, which is a voltage. We're going to be doing 1 volt. Just call this voltage 1 by default. And now this voltage should be 1 volt, but it doesn't have a reference now. So let's go to the bottom, select our face, assign excitation, and then voltage, and we're going to make this 0. This will be our ground. So now that we have this, we can add our voltage sources to the simulation by assigning a matrix and then including both of these. Hit OK. And now one more step, which is to add the analysis. You can do that by right-clicking analysis, add solution setup. We're going to do 20 passes with a percent error of 0.15. And then the convergence. This is just the number of passes it'll have to do to converge to a correct answer. We're going to just make this converge a minimum of 2 times. Now to actually simulate, just right-click on your setup and analyze. We're going to have to save this. I'm going to save this as Maxwell example. And through the magic of video editing, it's done. So now let's look at our results. These are contained in the results section down here. We can right-click, create electrostatic report, and then a data table. So to view our capacitance, hit C, and then you can select either matrix 1.c, V1, V1, or V2, V2. So let's hit new report, close that, and we can see our capacitance is 8.28 nanofarads. So next we're going to look at E field between our plates. So let's go back to our physical design here. Now let's select substrate and then our air box, because E field cannot exist within our good conductor here. So we can right click, fields, E, and then E vector. So we're going to view this in all objects and then hit done. So we can look at how the E field is distributed along our capacitor. So you can see for the most part it's going straight down, except if we go look at one of the sides, you have these arrows here indicating the fringing fields. Fringing fields exist in the air around it. Alright, so that was an example on how to use ANSYS Maxwell to simulate a parallel plate capacitor.